hijacking. So we have application session hijacks, we have network session hijacking. We need to deeply take apart the TCP/IP process and look at everything that goes on in layer 3 and all the way up to layer 7 in our OSI model. And we're going to talk about some of the advanced mechanisms and actually how this session hijacking takes place. And then we'll follow up with some of the tools that have worked over history, some that still work great today, and some that are a little bit outdated, but oh so fun when they were available. So we're going to cover everything from basics of session hijacking all the way to advanced session hijacking, and from the network layer all the way up to the application layer. So stick with me and let's get started. Hi, Leo Draeger here. This is one of my favorite subjects, cryptography. We're going to talk about all of the principles that are in play: confidentiality, integrity, availability, authentication, and we're going to talk about how companies use cryptography or secrecy to their advantage, but also how penetration testers can use secrecy to their advantage as well. So there's lots of different tools and techniques and different types of attacks. Now that's kind of the basic stuff here. But there's a big difference between what happens academically versus professionally. Academically, there's the whole history of modern cryptography and enough information to write college courses on this stuff. At the end of the day, professionally speaking, most of the time it's just simply click a button. Either you're going to encrypt something or you're not. Or you're going to hash something or you're not. So we're going to see how this works in the world and why people aren't taking advantage of simple things like hashing, and how the penetration tester can take apart that process and use it to his or her advantage. So let's go ahead and start with the basics of cryptography. Hi, Leo Draeger here. This is one of my favorite modules, sniffing and analyzing traffic. Out of all of the years that I've done this, I boil it all down to analyzing traffic, or analyzing the signature of information as it's moved across the network. So this is a lot of fun. At the end of the day, it's packet analysis. Also, what is critical in this section is to realistically take an OSI model or DoD model approach to this. You need to know how layer 3 things behave versus layer 2 things behave versus maybe something like layer 7 or the application layer. So knowing your OSI model is really, really helpful here, and then actually sniffing or analyzing the traffic. There's a variety of tools in which we can use to analyze traffic. Common ones being things like TCP dump or the classic Wireshark, but then there's also shortcuts that you can take like T-Shark, which is a terminal Wireshark front end. Ultimately, we have to focus on what happens at the OSI model and the different layers of it and the different signatures which our applications identify themselves as. So part of this will be just taking something as simple as DHCP and analyzing the process, or sniffing the DHCP process. Also, how do MAC addresses naturally work on a network? This is also critical, because if you know how they work and you know what normal behavior is, well then you can start doing things like ARP spoofing or MAC flooding and some of the more advanced attack techniques. Also, DNS. Taking apart the DNS process, looking at name resolution from literally a traffic analysis standpoint. And then you can spin that off into just about any other application you want. How does LDAP look from traffic analysis point of view? SMTP or mail or POP3? What's in clear text versus what is encrypted? If it is encrypted, what can we see from the outside or the wrapper portion of that? Can you tell what types of algorithms? Is it symmetric? Is it asymmetric? So by dissecting the traffic and sniffing and analyzing the traffic, you can tell exactly what's going on a network. So this is the raw traffic. Now, most of this we're going to use for the principle of disclosure or the principle of confidentiality, but there's a lot more to it than that. It's understanding how traffic works on a network and how to use that to your advantage as an attacker. So let's go ahead and spend some time really digging into using these tools. So in the beginning part of the module, I want to show you some basic techniques just using the tools. But when we get to the advanced penetration testing for sniffing, I want to show you how to make your life easier and using some command line options that ultimately are just going to make your life really, really easy in terms of documentation and reporting. So let's go ahead and get started. Hi, Leo Dreger here. This is one of my favorite modules, wireless penetration testing. There's so much to do wirelessly these days. The applications in which we penetration test systems, they've come leaps and bounds over the last 10 years. Now, it all starts with encrypting our networks. All right, so there's multiple types of encryption. We're going to take apart WEP and WPA and WPA2 and all that fun stuff. We're going to look at the different types of attacks, whether it be attacks on integrity, attacks on confidentiality, attacks on availability, like rogue websites and things like that, knocking access points offline. The whole war driving concepts, whether you're driving a car or flying a plane or using a drone nowadays. We'll look at the full wireless spectrum, how we can use that to our advantage, and we're going to spend a lot of time on the most popular tools out there. So literally the latest and greatest stuff. But before we can get to the advanced stuff, we got to start one foot in front of the other. And we're going to start from the beginning and go all the way to the end. We'll cover a little bit on Bluetooth, only because that's still considered wireless, but that's realistically its own module. And then lastly, we'll wrap up with how to defend against people poking and prodding your wireless networks. So let's go ahead and get started. Leo Dreger here. In this module, I want to talk about attacking the web server in itself. Now, in today's networks, you're going to hit a web server sooner or later. There's a lots of interrelated components, everything from how do the web servers communicate with databases, and that opens up a whole nother Pandora's box like SQL injection or any sort of database injection. We're going to talk about the popular web servers like Microsoft and Apache, but then some of the not so popular ones as well. We're also going to talk about how to do a lot of the stuff manually in the beginner section, but in the advanced section, I really want to start using advanced tools like Metasploit. So that's going to take off dramatically once we get to the advanced section. But all of this stems around the client and server architecture, the protocols that they use, and the methodologies in which you can manipulate to ultimately get information disclosed to you, or to change something on the web server itself, or how it's connected to a database. And then we'll follow up with some best practices like patch management and logging and monitoring to make sure that if somebody is attacking your web server, you know how to react to it defensively. So we'll start off offensively, but then we'll follow up and finish defensively. So lots to cover in this module, so let's get started. Hi, my name is Leo Dreger. In this module, I want to talk about the various aspects of footprinting. Footprinting is a very important concept in the world of penetration testing because information is naturally disclosed everywhere. And so what the penetration tester does is he documents all of this information, and the information can come from a variety of sources. So some of the information is going to be about our target. For example, it could be our organizational websites, directories, anything regarding email. Ultimately, we're going to have to reach out and we're going to have to touch a system. So this is where IP addresses, domain name blocks, rogue websites, access points all become very, very important. Some of the threats that are possible with just footprinting in itself is, could the information that you've gained here, could that be used in a social engineering attack? Could the clients be subjected to a financial loss of some sort? So we're going to cover a lot of the tools and techniques that we would actually use. Most of these are available over the internet. At least I would start there. These would include things like job sites or anything that's realistically on the internet. Job sites, social networks, posting boards, and things like that. Now, in the beginning part of footprinting, it's really documenting all of this, but we're also going to cover some of the advanced techniques as well, and I'll show you how, instead of you having to go find information about your target, well, the advanced concept is you want the information to come find you, and I'll show you how you can use alerting websites for that. The biggest component here that we're going to use to dissect our target is going to be the public registration of our target, which is the DNS information and the WHOIS information. Also, we're going to use email to our advantage as well. So that'll cover the basics of footprinting. Now let's get into the really good detail. Leo Draeger here. I want to talk to you about viruses and worms. This is a very fun section. Now, most of us have experience with a virus or a worm in some sense, meaning that we've been a victim at some point. This is why we all run antivirus software. But there's a lot more that goes into it. So now, from the eyes of the penetration tester, you get to construct these viruses and worms yourself. Ultimately designed to trick the end users into clicking on it or executing your applications, which is a lot of fun because it's either hit or miss. It either works or it doesn't. You're either going to be caught by antivirus or you're going to evade it completely. So let's talk about some of the basics here. There's the stages of basically viruses and worms. Somebody's got to create the virus and worm. Somebody's got to deploy it out there. It's got to be replicated. It's got to infect systems. Then ultimately there's going to be some sort of detection mechanism with that. Then antivirus signatures and the different ways to detect viruses and worms need to be created. And then also the countermeasure needs to be deployed. So there's a whole life cycle involved with viruses and worms. So the interesting part about this whole module is that it stems, it has its root with malware analysis. So it's its own field of study. So there's multiple types of viruses, whether it be metamorphic or polymorphic. We'll get into those as we cover the labs, but there's multiple different types. Also, the popularity of applications has skyrocketed at this point. Well, it used to take a lot of knowledge and skill to create viruses and worms. Nowadays, you can actually use virus construction kits or worm construction kits. So I'll show you how to use those as well. Also, we're going to talk about the countermeasures. And real quick here, there's really three major areas in which you can detect viruses and worms. There are three different major categories. You have an integrity-based approach. This would include things like hashing systems, kind of like software like Tripwire, in which if anything changes on that system, well, your signature or message digest will change, and therefore you'll be able to detect that infection. The next type is knowledge, signature, or rule-based. Kind of different words for the same thing. This is its own category. But the magic to this type of detection mechanism is somebody has to have the knowledge to write the signature. If you don't have the knowledge to write the signature, there's no way for you to detect it. And then lastly, there's the final category, which is profile, anomaly, statistical, or behavioral. Again, different words or different techniques realistically to discuss the same thing. Now, these are important because this is where we baseline a system and define what good behavior is. Once we know what the good behavior is, well, then anything not recognized is automatically flagged for the administrator to review. And then we'll discuss some of the common countermeasures and common antivirus style software that's out there. So this is a really fun section. So I look forward to seeing you in the labs. My My name is Leo Dreger. We're going to cover the penetration testing, scanning, or Module 3 or Phase 3 of scanning. Now again, we're going to use disclosure to our advantage here. Notice we're halfway through the life cycle and we're still focusing on disclosure. A lot of people ask, hey, how did you hack into this or how did you hack into that? Well, hacking actually comes when you gain access to the system. But notice all of the legwork that goes up to gaining access to these systems. These are not just magical hacks. In Phase 3 of scanning, we focus on gaining as much information about our targets, more so than we did when we talked about footprinting. Except we're going to use a variety of different tools here. We're going to look at port scanning in terms of reaching out to our host and figuring out what ports they have opens. The basics here is basically just performing the port scan in itself, where in the intermediate steps of scanning, this covers advanced scanning techniques, where in the actual advanced module, this is where we get into as much detail, as much granular detail as we can about our target and our hosts. Okay, so we'll also talk about some of the IDS invasion techniques. We're going to talk about how to use fragmentation to avoid detection. We're going to look at the different countermeasures that get put in place so that people can't detect that we're scanning. We'll talk about accessing systems that aren't conventional anymore, like war dialing. We're going to talk about using proxies to hide our source. We're going to talk about using Tor and things like that. And then ultimately we'll wrap it up and we'll talk about the actual countermeasures that are used. So there's lots of detail here in this scanning module. So let's go ahead and start and get our hands dirty. Leo Dreger here. Now, in the last module, we talked about the web server components in themselves, but now we get to talk about the web applications. And this is literally Pandora's box. There's so much to talk about. This is a jam-packed module because we get to tie everything from the old and the new in together, and then attack it and exploit it all. All right. So some of the attack vectors, you got to look at the basics here. What is the architecture in the way that the web server is set up? So that if you know that, then that tells you exactly how to approach the attacks. Now, your traditional threats, or confidentiality, integrity, and availability, they still exist. But there's other principles involved that are very, very important as well. For example, authentication, authorization, and session handling as well. Also, we get to tie in a lot of the newer technologies because most of our web components, like mobile phones, our iPhones, and our Androids, they connect to web-based dynamic content, and there's realistically so much to talk about because you have search capabilities, you have social networking, you have mobile applications, you even have registration components and things like Ajax, which really just enhance the user experience. So whether it be just something as Wikipedia or email or instant messaging, all of this gets tied into the web application. Now, what works very, very well for us in terms of the penetration tester is most software developers are not security engineers, and most security engineers are not software developers. So only in the last 5 or so years has that world actually been coming together. But they've been very resistant to actually doing it together. Okay, so the whole life cycle in which applications get developed, we can basically take that apart and exploit that. Also, the hacker has a huge head start here because how long is it going to take for company X to go ahead, find a vulnerability, go ahead and write out some code to fix it, take it through their patch management process, move that through the change control process, and ultimately get it to the point where they've fixed their problem. So the hacker has a huge head start. So between all of the technologies that we bundle together here and then all of the lifecycle components, there's lots of room for penetration testing. Now in this particular module, there's so much information here, it could be its own 5 to 10 day course. As a matter of fact, most of the time while I'm teaching live, the most common critique is, man, I wish we had more time. So we're going to move very, very fast through this module, but nonetheless, you can take it apart one step at a time. So let's go ahead and get started. Hi, Leo Dreger here. We're going to talk about SQL injection. Now, at first you may think, hey, that's just a database. What could possibly go wrong, right? Well, most web applications connect to some sort of back-end database, whether it be MySQL or Microsoft SQL or Oracle or any other database. Databases are basically a file of stuff, all right? But we're going to look at that file and all the information in the databases, and we're going to see how that plays into the whole session here. Okay, so we're going to look at the different SQL injection attacks. We're going to look at ways in which a company or a client can defend against SQL injection, the different types of, well, is it even possible? Are you working in a way in which you can see the results of your attack, or are you working completely blind, right? I like to kind of use the example of you're just poking and prodding around and you can't see what's going on in front of you, working blind, because in many cases, if you can't get the error messages or information that's disclosed to you, how do you know if your SQL injection attack worked? So we can start off at the basics. We're going to cover everything from, well, what is SQL injection, but we're quickly going to move into the advanced SQL injection attacks. One of my favorite things to do in the introduction of SQL injection is just Google SQL injection and see what you come up with. There's loads of information out there in which you can learn this very, very effectively. Now, it takes years and years and years to become a seasoned database administrator, and only seconds for an attack to basically be realized. Okay, so we're going to look at everything from getting our applications and our operating systems to execute code for us, whether it be command line or some sort of web application to do it for us. We're going to look at bypassing log-on information and basically poking and prodding around the web application and the database relationship to get the applications to do what we want. We'll follow up with the different types of evasion techniques so that we don't get caught as a penetration tester, and then how companies can defend against themselves. So stay tuned, we're going to get started right now. Leo Dreger here. I want to talk about Module 6, which is Trojans and Backdoors. Now, in the last module, we talked about gaining access to a system and finally changing the integrity of our targets. But we can extend outside of the hacking lifecycle or the penetration testing lifecycle and really move in an a la carte fashion at this point. Trojans just happens to be one way in which we can get information executed on our system. So we're going to talk about the different types of Trojans, the different signatures that a Trojan gives off. Mostly that has to do with the ports and signatures, which is very, very important because as we're trying to get the Trojan implemented to a system, the defensive countermeasure here is companies or clients, they're trying to protect it and prevent not getting infected. So we'll talk about the common signatures or ways to avoid detection. We'll talk about how to construct a Trojan, and this realistically goes into the concept of Troy, or the theory of Troy, in which we have an overt application and a covert application. Overtly, we're going to put an application or some sort of distractor in front of the end user, while covertly, we're going to be dropping a backdoor or some sort of root level access to our systems. So we combine these two concepts, overt and covert, combine them together to create a malicious application in which we hope that the user executes. Once the user executes this application, while they're distracted, we're getting access to the back door. We're also going to need to be notified that, hey, the Trojan has been successful. So we need a way for the Trojan to actually communicate back to us and say, yes, I've been successfully installed or implemented, so come take advantage of me. So we'll talk about the different types of Trojan analysis. We'll talk about countermeasures and the different types of anti-Trojan software, which basically you can boil down to antivirus, although there's a couple other techniques. So keep in mind, the focus here is getting access to our systems, changing the integrity of them, tricking our users, taking advantage of that, and all of the countermeasures and detection mechanisms. Because if you know those, well, then you can increase the likelihood of dodging those checkpoints and getting your software infected on your system. So let's go ahead and get our hands dirty. Leo Draeger back here with Module 4, enumeration. Now, again, we're focusing on disclosure. We haven't changed anything about our targets yet. Eventually we will when we get to gaining access to our targets. But right now we're still going to get a little bit more information about disclosure. So in this module, I want to talk about what is enumeration, the different types of things that you would enumerate, like, for example, our ports and our protocols, like NetBIOS versus TCP/IP or whatever protocols we have to our advantage. I want to show you how you can use Google to get as much information as you possibly can. Simple Network Management Protocol can be a wealth of information if you have access to an internal network. Also, we're going to reach out and touch things like Lightweight Directory Access Protocol, or LDAP, or some sort of directory service. I'll also talk about the importance of the Network Timing Protocol, or NTP, port 123. Easy way to remember that is time starts with port 1, 2, 3, so it's port 1, 2, 3. And then we'll talk about simple mail transfer protocol, or mail in itself. Then we'll finally wrap up with some countermeasures. So this is going to be the last module where we're exclusively talking about disclosure before we actually get into our attacks or hacks, if you will. So let's go ahead and get our hands dirty. Hi, Leo Draeger here. In this module, I want to talk about buffer overflows. Now, we're going to need to start thinking like machine language, a computer, because this is how does a computer store things in its memory, and how can we manipulate that process? Now, it's basically pretty simple. I want you to imagine an ice cube tray, right? This is a modular framework. So if you put too much water into one cube, it overflows into another. Well, memory sort of behaves the same thing, but every ice cube is its own application or its own space. So that's the basics. Now we're going to cover some of the different tools and techniques that you can use, and also cover the different types of threats and the different types of software in which we can use. But this is a specialized field of study because you realistically you really have to think like a programmer in this sense. So let's go ahead and get started. Let's talk about buffer overflows. In this module, I want to talk about the theory behind enumeration. And now in the previous module, scanning, we basically only wanted to find out if a target was on or off, or the ports were open or closed. We only wanted some basic information, port scans, vulnerability scans, and things like that. But in enumeration, what we're really asking here is, can I have more? And it's highly targeted. Okay, so let's look at this. The principle that's involved is still confidentiality oriented or disclosure oriented. Notice we still haven't changed the integrity of our target yet. We're going to get there, but most of the life cycle of penetration testing is what information is available to me, documenting that, and how can I combine all of that like a puzzle and ultimately form the actual attack. So we're getting real close to penetrating a system, but we're not there yet. So let's look at enumeration. Obviously, you're going to be running some tools against the target. So between you and your target, once you reach out and you talk to this target using your tools, what information is available to us, or what would we be interested in? Well, the first thing, and this can be in no particular order here, but the first thing is what layer 2 or layer 3 information, because most of this we've probably already got from the scanning section. So what routing tables, how does the routing table look? How do the ARP tables look? So a few of the tools will disclose that type of information. Also, on our target, what users, groups, or accounts are available? Can I start enumerating lists of those? I mean, if I could reach out to Active Directory and pull a list of all user accounts, that's a treasure trove of information. Or what if it's not connected to Active Directory? What if it's a standalone system? Or what if it's a Unix system? Or is it even tied together at all? Right? So the result of users, groups, and accounts, that tells you the makeup of realistically how your target is connected to the rest of the network. Speaking of that, network resources, okay? Are there any printers connected? Anything related to networking protocols specifically, like TCP/IP, NetBIOS, server message block, any of that stuff, all very, very valid, which spins directly into services. So think of going to a client machine and looking at the particular services that perhaps Windows is running or Unix is running. If we can enumerate that list, that maps out the surface area of attack or potentially doors to get into our target. Also, what names or naming conventions do they use? Is it a DNS name? Is it a NetBIOS name? Is there no name resolution? Can you only talk to it with TCP/IP? Or maybe it's a router that doesn't use a naming convention. All of this starts to paint the picture of what exactly our target looks like. Then we can go even more in detail and say, well, if we know the services and the ports and the protocols, well, can we get even more information by connecting to the application and pulling some of the application code or the application banners? So that's very, very important as well. And then, of course, at this point, you could start getting passwords. That makes the next part of the penetration test really, really easy, because you're halfway to getting to access the system with a username. If you could get a password at this stage, great. That would be considered the holy grail, and boom, you're in. And this is where things like a null session come into play. All right. Also, high level, what type of operating system are we attacking? Is it a Windows, Linux, Mac? Is it a networking operating system like a router or firewall or whatever web interface we can connect to of that type of operating system? All right, so that's a little bit of theory on what you're going after when you talk about the target. Next, I want to talk about how do we connect to this target, and that's where our ports and our protocols come into play. Okay, let's just do the whole thing first. NetBIOS, Simple Mail Transfer Protocol, LDAP or Active Directory, Network Timing Protocol, Server Message Block, and DNS, and Simple Network Management Protocol. All of these together are the basics here. Now remember, there's how many ports? Right? We have up to 65,000 ports in which we can connect to. That's a lot of services. But your 80-20 rule tells us that only a handful of them are going to give us the most information. So this is where we start, because these tend to be the most rewarding in terms of time versus effort. Okay? So NetBIOS, typically only on a Windows system, and there are a handful of systems that still use this. This is a much older protocol, but if we can connect to it and speak the language of NetBIOS, we can get lots of good information here. Mail. A lot of systems use mail, whether it be email between users or perhaps replicating directory information. SMTP can work there as well. If there is a directory, what can we get from that directory? And this is where any sort of directory protocol would be fair game. The common ones are LDAP and Active Directory, but remember there's others. You have Novell Directory Services, or anything that ends in directory services would be fair game under that category. Timing. Is there a timing component? Server message block, very similar to NetBIOS, but nonetheless it's different, and the exploits are, I would consider it in a separate category as well. DNS, this is a little bit more name resolution oriented, which would kind of map to our component of, naming and how do we connect to it, but nonetheless, you can get lots of really, really good information, especially if Active Directory, which would be an internal directory structure, is integrated into an external DNS. If those two talk to each other, Pandora's box opens wide open. All right, so you must master tools like NSLOOKUP and DIG. All right. Also, with Simple Network Management Protocol, this is also a treasure trove of information, because if you can connect using the default public and private community strings, man, you can get a wealth of information, and in many cases even go into full-blown administration of a network appliance. And we use a management information-based browser. The best way to describe a MIB browser is think a web browser to connect to networking resources, and there's plenty of ones that we'll look at. And then you can summarize all of the protocols with, well, what ports do they respectively talk on. Now, I've listed a few here, but it's certainly not limited to this. This is where your typical system administrator tends to break down in the subject of penetration testing, because they may know a few ports and protocols, but the goal of ethical hacking is to be able to find all ports and protocols, quickly look those up, and be able to do something with them. So your common ones, this is where you can play quiz to yourself here. What is port 53? If you were thinking DNS, you're right on. When do we use ports 135, 137, 139, 445? Those are common Windows-oriented ports. Or ports 161 and 162 for Simple Network Management Protocol. Or 3368 for Global Catalog Services, or 389 for LDAP, or 3389 for Remote Desktop. And again, there's plenty of derivatives. So if 3389 for Remote Desktop's not open, what about other ports like VNC and things like that? Okay, so let's take a step back and let's summarize before we get into the hands-on labs. We're still focusing on confidentiality. We're going to get ready to go change the integrity of our systems coming up here, which is often considered the hack. So between us and our target, we look at routing tables, users, groups, accounts, networking resources, services, names, application banners, and passwords. We want to find out as much as we can about our operating system, and we can attack any protocol or port that is available to us. But now, in the context of enumeration, remember, we want more. We should have enough information at this point to start really getting into how the system is vulnerable, what is offered to us, and how do we actually exploit that target system. Are conventional exploits going to work? Maybe something like Metasploit? Or do we have to go into unconventional methods like social engineering, shoulder surfing, and dumpster diving? All right, so let's go ahead and get started with some hands-on examples. Okay, folks, now the moment you've all been waiting for. Before, we've only focused on disclosure, what's been available to us, and how to take advantage of that and put together this amazing puzzle piece of protocols and ports and access and theory, etc., etc., etc. Now's the point where we actually get to change the integrity of our systems. This is what we refer to as the classic hack. So let's take a look at it. Remember, ourselves to our target. Ultimately, we want to gain access to our systems. So there's different ways in which all of this you have to master, but there's different ways in which you can break this down increment by increment and look at. First, gaining access to the system. The easiest way, of course, is going to be a username and password. So how do we get those? One way, eavesdropping. It's just as simple as that. If you could either look over somebody's shoulder and get their password, or it's written down somewhere, or nonetheless, you have that password, that's the holy grail, okay? If you don't have it, then we have to get it some way, and we have to use our creative social skills to actually do that. This is where your traditional brute force attack, or exhausting all possible combinations of the password, that's where that comes in. Or dictionary. This is where you take a password file and you reference it and compare it against a file of stuff. And in that file could be literally anything. Then defaults. You could just Google default usernames and passwords. If that gets you access, great. low-hanging fruit, or the hybrid technique, which is traditionally brute force and dictionary. At a minimum, you must master these ways of gaining access to a system. Once you gain access to that system, then, okay, let's get more privileges. All right, so this is where exploits come in, or additional password cracking techniques, because you might have access as a guest, but now you want to go after the administrator or some other higher privileged account. So there's two ways in which we can summarize doing that: horizontal privilege escalation and vertical privilege escalation. Horizontal, going from group A to group B, versus vertical, going from guest to administrator. Okay? Once we gain access and can get some privileges, even if they're low level, this is where we ultimately want to start having our applications or malicious software executed on that system. So executing application. This is where the whole world of Trojans and spyware and viruses and worms come into play. It's its own separate module, so we'll see that a little bit later on, but I will give you the basics of how the tools works. Keyloggers, whether hardware or software. This is some really fun stuff, because if you can just, put a hardware or a software-based keyboard logger on a system, you can capture everything that person types. Even better to be able to do that remotely. All right? We need to do this so that ultimately we can put our own backdoor, execute the application for our own backdoor on that system, so that way we can have our way with it whenever we want. All right? Next, once we get our applications to execute, we got to be able to hide some stuff, right? This is where rootkits come in play, because ultimately rootkit gives you backdoor access to the system, and you don't want to advertise, hey, I've got access to your system. All right? It doesn't work like that. You have to be very, very covert and hidden in that sense. This is also where alternative data streams come in. This is such an easy technique to do, but very few people know how to do it. This is something you should be able to do on the fly. Boom, alternative data stream, done. That's simple. Stenography. Notice I have some stars next to keyloggers and stenography. These are separate areas of expertise. Literally, that's its own Pandora. The system administrator trying to track you down. All right? Now, you do have some things working for you as a penetration tester. I love it when system administrators go to check the log files, because most of them, with all due respect, have no idea what they're looking for. They open up the log files and they go, yep, nothing to see here. They wouldn't know what was in front of them if you put it in front of them. All right? Not to really attack the system administrators, because we've all come from that world in some way, shape, or form. Very, very important. But log file analysis is just a lost art. Okay? And so the penetration tester has to know way more about log file analysis, has to be an expert in log file analysis, more so than the person looking in the log files. So compared to offense versus defense, the penetration tester must absolutely master log file manipulation, or else go to jail. Okay, in the black hat world, in the the ethical white hat legitimate world, basically alarm sounds, you get caught. So if you're doing some sort of analysis and you're not people aren't supposed to